Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2008 Subaru Legacy. This little Subaru has a problem where it's setting cam sensor codes for bank 1, and apparently it had misfire codes set for 1 and 3. So what I first want to do is I want to get a scan tool, and I want to get some very basic data out of this car. So let's go ahead and get that scan tool connected. Okay guys, the shop I'm doing this work for, when he first started to do the work, he made a printout of the codes, and this is that printout. So he's got a P0340, which is bank 1 camshaft sensor circuit malfunction, and then he's got a secondary air injection problem, and then he's got a misfire on 1 and a misfire on 3. Now, the DTC for the cam sensor, he replaced the cam sensor, and he's fixed the air injection problem. It had some hose problem. And the misfire on 1 and 3, this car had the wrong spark plugs in it. The spark plug they had in there was a real short plug. It didn't even go down into the chamber. He's put the right plugs in it, and he's fixed the misfires, and he's fixed the air injection, but he still has a cam sensor code. So let's take a look at those codes now. What I want to do is I want to come over here, and we're going to open up the DTCs, and we have a P0011, which is the cam position sensor for bank 1, but this has a timing fault now for over advanced. So with the new sensor in there, it's setting a different code now. Now the misfire and the air injection, they're no longer setting a code, but we have something going on with this cam sensor on bank 1. So the first thing I want to do is I want to get a scope on this, and I want to look at the cam and crank sensors together, and I want to see what's going on. Why is this guy setting a timing error now? So let's go ahead and get that scope on this vehicle. Okay guys, let me show you how I've got the scope connected. I've got channel 1 yellow connected to the cam sensor for bank 1. I've got channel 2 red connected to the cam sensor for bank 2. I've got channel 3 green connected to the crank sensor, and I've got channel 4 connected to an eSCOPE, and I've got it on the number 1 coil. Okay, I want to go ahead and set the scope up. So I want to come to channel 4, and I want to go to a 20 amp. That'll give me a 10 times multiplier. Then I want to 0 that one. And then we want to come over here, and now's what I want to do is I want to load a known good waveform. So this is this 2.5 turbo motor, known good. The cam is on yellow, bank 1, cam bank 2 is on red, and the crank is on 3. So let's go ahead and take a look at this. So now this is our waveform. So the first thing is the bank 1 is being pulled down and bank 2 is being pulled up. Notice they're inverted from each other. Now, this is the way they should be. The next thing I want to do is I want to take a cursor down these edges . And we can see that these edges line up pretty close. And they're basically, these edges are aligning with the last pulse before the index. You can see it's almost coming through the peak. This is the index point. And this is the single index point, and these two are lining up with the last pulse before the single point. So that's known good. Now let's get a waveform off of this car. We already have a problem, guys. So we already have a problem the two cam sensors are inverted. The bank 1 should be being pulled down, and bank 2 should be being pulled up. Those are not right. Those are inverted waveforms. So there's something wrong right here. Now it's only setting a code for bank 1, but both sensors have an issue. Remember, in the known good one, watch. This is what we have on this car. I'm going to load with known good. Turn off the... See, bank 1 is being pulled down and bank 2 is being pulled up. And that's not what we have here. Yellow's bank 1, and it's being pulled up, and bank 2 is being pulled down. Bank 1 is being pulled up, and bank 2 is being pulled down. These are inverted from each other. That shouldn't be the way they are. So this has something to do with the sensor, because the computer is feeding the 5-volt signal out, and the sensor is pulling it to ground and releasing it. And these are just swapped. So that's crazy, okay? That's pretty crazy. So again, we can clearly see that bank 2 is being pulled down and bank 1 is being pulled up. These are exactly opposite of what they should be doing. So one thing I want to do, okay, I want to give this a little rev and see what this is going to do. Okay, so bank 1 flipped and now it's correct, it's being pulled down, and bank 2 is still being pulled down. This one's wrong and this one's right now. Wow, holy moly, that's insane. Look at that, guys. Bank 2 is being pulled up the way it should be, and bank 1 is being pulled. They're right there. That's right. And look at right here. It flipped. And when it flipped right there, now it's wrong. But right here, it's right. So these are the way it should be right here. Now, let's turn this guy back on. Okay, right here, it flipped. That's right. Bank 1 is being pulled down, bank 2 is being pulled up. Now that we're correct, is what I want to do is I want to see if it's in time. Okay, so that's my double piece. That peak right there should line up with them. It's off just a little bit, but it doesn't look like it's far enough to set a code to me. The difference is between that peak and where we are. This is what I need to do here. We're going to go from the first peak to the first peak. I'm going to mark it. Now is what I want to do. So I want to measure the difference between the edges. So that last peak right there to the edge is what we're interested in. And we're 11 degrees. You know, 11 degrees might set a code because that's more than 10 degrees for your cam. But I don't think that that's what's wrong, because we can clearly see what's going on, and it's flat. See how they're both going the same way now? These should go in opposite directions. Well, if we're measuring the edge, do you see how if I looked at that edge, it's way off from this edge? And that's a lot more. So if I get my cursors here, the edge to edge, look at how many degrees we're off there. It's a huge amount. So that's not, the reason that the car is setting codes is because, guys, the reason the car is setting codes is because they're flipping, and both of them, both sensors are flipping, guys. Did you see that? Bank 1 and bank 2 are inverting from each other. Now, that's insane. I've never ever seen a problem like this. I mean, right now I don't even have an idea of exactly what to check. I don't know what would cause that. I mean, to flip the magnetic intensity like that, the only thing I can think of is the shafts might be magnetized, but there's no way I can magnetize both cams. So maybe I'm thinking I need to check the alternator and see if it's got a diode leaking. Maybe a bunch of AC could do this, but the only thing I can think of right away that would cause us a problem like this is the wheel is magnetized to flip them both. And both of them flip, and it happens when we change the speed. So if we go back out, okay, bank 1 is being pulled down and bank 2 is being pulled up. That's right. Right here, bank 2 started to be pulled down, and it needs to be being pulled up like here, and it's flipped. That's crazy. Let's do this again. I just want to see this one more time. Let's rev this thing again and see what happens. Right here, bank 1 is being pulled up, and it should be being pulled down, and bank 2 is being pulled down, and this is wrong. So both of those are wrong right there. And right here, it flipped. Do you see how it was being pulled up, and now it's being pulled down? And that's right when we started to rev it. We can see it because the crank sensor gets bigger. Because the crank sensor is a variable reluctance. The faster it goes, the bigger the signal got. We can see right when we started to rev it, it flipped. And then look over here at bank 2, it flipped. In fact, they flipped within 327 milliseconds of each other. So they both flipped, and they're both flipping. Now guys, that's insane. I've never seen anything like that. You know, I keep coming out here and working on cars, and then I just get these crazy, crazy cars. Because guys, that's one crazy problem. How can both sensors flip and they're flipping within just a few hundred milliseconds of each other. What would cause that? Maybe the AC ripple off the alternator. So I want to go ahead and I want to change, put a lead on there, and I want to look at that. So let's check the alternator real quick and just see what that's doing. Okay guys, when you check alternator ripple, you've got to be on the alternator. Never check this at the battery, because the battery acts as a big capacitor. So I want to be at the alternator, and that's what I need. Okay guys, this is the alternator. So take your zoom window. Do you see all these humps? 1, 2, 3, that's the 3 diodes. 1, 2, 3, that's the diodes. What I'm looking for is one of these to be falling more and more. Like one of them has a bigger output. Now this is at idle, and this is not where I had my problem. And what these are is where things are turning on, like coils and injectors are turning on. These are voltage drops. I don't care about the voltage drop. These drops right here, if one of them drops way more than the others, that's one leaking. And if like right here, that sort of looks like it could be leaking, there would have to be 3 away again. 1, 2, 3, and that one's not dropping more. If it's leaking, it will be every third one. So now is what I want to do is I want to rev it like I did before when I got the car to fail. Okay, so now I want to take the zoom window and we want to come in over here where we revved it, right in here. And again, where these drops are is where things are turning on and off. Don't worry about that. See how I have good 1, 2, 3, 1, 2, 3, 1, 2, 3, and none of these are dropped way lower? These need to start dropping down further than maybe half a volt before I'm going to worry about it, or a volt. They got one of them will start dropping, but it will be very repetitive. And I don't see that dropping. So no, the alternator is fine. I don't have alternating current that's tripping this up. It's something else. And the only thing I can think of right now would be magnetized trigger wheels. The faster that trigger wheel goes, the less magnetic energy remains on that circuit, and then it flips it right. And when it's going slower, it's got too much magnetic field on it and it flips the sensor. Let's see what we had happen down there with the sensors. We didn't look at that, but I'm interested. Did it do it again? And right away we can see that we inverted right here. This is wrong. It's being pulled up. It should be being pulled down. It went correct right here. And this one should be being pulled up. It's being pulled down. Do you see how both of those are inverted? And right here it went right. So let's turn that guy off. Do you see where it flipped right there? So let's see what it did this time. So that's where it started to work right. And that's where that one started to work right. 116 milliseconds. These are happening really close to each other. And once again, it happens right when we start to accelerate and that shaft starts to turn faster, is where they get fixed. And when it's turning slower, they're both inverted. So let's check it now. So right away it's going slower and they've inverted again. This one should be getting pulled down and this one should be being pulled up, and they're not. So I can't, what I'm blown away with, How is this not setting a code for both banks? It's only setting a code for one. That's crazy, guys. This is one crazy car. Wow. That is a crazy car. So right now, these are wrong. So what I want to do this one more time. I always like to see these things happen multiple times before I start chasing my tail. Let's speed it up and see what happens. So we're pulling down and we're pulling up, so this is right. And this is wrong. We rev the car and it gets right. We idle the car and they're inverted, and it's both sensors. And I'm just not sure what would cause that. And let's see this time how far away those are from each other. As soon as we start to spin the engine faster, they both flip 135 milliseconds. So whatever is affecting both of them, it's really close to the same time that they're occurring at. They're both flipping as soon as we start to spin the engine faster. That's the data that we can clearly see what's happening. They both flip when we spin the engine faster. I'm just not sure what would cause that other than a magnetized target wheel. Okay guys, in order to see what's going on with the Subaru, the easiest way for me to check to see if the shaft is magnetized, the trigger area or the trigger wheel on the camshaft, is we just remove the valve cover. Once I remove the valve cover, and we also remove the sensor, so I don't want any magnetic energy down there that might trick us. So the sensor's been removed and we remove this valve cover. And there's a ground that's on the head that was not on the head. It doesn't go to the valve cover, it goes to the head itself. And there's a ground cable that's supposed to be connected to that head that has been off for some time. And you know, when you get these grounds and they're not on the engine right, that's what gets these shafts magnetized. So now let's go ahead and check this shaft with the instruments I have here to check for Gauss or magnetic energy. Okay guys, when we pulled the valve cover, this ground is supposed to go over to this head, and you can see that it hasn't been connected. Do you see how rusted it is? That ground has not been on this head for quite some time, and without having this ground cable on there, it changes the current path and it's magnetized that cam now. You can see the little cutouts in the cam. That cutout is what's making the cam sync. So it has cutouts around that cam, and that's what syncs that cam. Okay guys, so I have two tools that we're going to use to check for magnetic intensity. First, I've got a drill bit that's magnetized, so let's just make sure that this is still a magnet. Okay, clearly that drill bit is magnetized. We can see that it's holding a magnetic field and it's holding that band clamp. So now what I want to do is check this. This is a sensor probe right here. And we want to cross that 5, 12, 4, 2, 6, 4, 5, 6, 7. I'm just moving it back and forth right in front of that bit, and we know the bit is magnetized. It's definitely magnetized. So we can see this reading right up here is going to change when it's in front of that magnetic field. So if this is reading any kind of magnetic field, we're going to see we're going to get a reading 3, 2, 10, 4. So the bit is definitely magnetized and it's showing it. The second one I want to show you, you can download on your phone. So if this is magnetized, now you can see the little pointer goes up into the yellow. The higher it gets up into the yellow, the more magnetic field this is. But we can see that it's getting into the yellow there. So it definitely is showing a magnetic field. And it all depends on the angle you are to the field, to how good you're going to read it. So reading these on some of the engines is going to be more difficult, because to get it down next to this camshaft might be difficult. But we'll get some reading. If it's magnetized, we'll see it. We can see that little marker going into the yellow. And when that little marker goes into the yellow, now I want to show you the difference between a real magnet and a piece of metal that's magnetized. Now this is a real magnet. We can see we're in the red clearly with this. And we'll also check this and we'll see that a magnet's going to make this operate quite differently. 41, 105, 126, 189. It's got 130. It's way bigger numbers because this has a stronger magnetic field. But something like on a crankshaft or a camshaft that's become magnetized, it's going to become, it's more like this drill bit. It isn't going to be in the hundreds. 14, 5, 4, 5, 3, 4. It's just going to show a light magnetic intensity, and that's it. It's not going to be in the hundreds. If it's in the hundreds, it's a magnet. And the shaft, they're not going to be fully magnetized. So again, we're going to be able to see that we've got a magnet. We can see that it definitely reads it. It's getting into the yellow, and this is definitely magnetized. And the other thing is the angle that these are at changes the field and how it reads it. And we can see that the angle is going to change that. So depending on how you can get your sensors to read the intensity from the magnet is going to change how it's going to read it. But we can see that this is magnetized. We definitely know it's a magnet, and we definitely can see that both of these instruments that I'm going to use show that this is magnetized. So if these cams are magnetized, one of these or both of these should show that cam is magnetized. Let's go ahead and get testing, and let's test this shaft to see what's going on. Okay guys, 7.5, 5.8, 4.3, 3.6, 5.6, 7.8. I'm just moving the probe on this trigger wheel back here. 6.5. Do you see it picking up that magnetic field, the intensity? 3.8, 3.6, 5.1. Okay, so that's me moving this on the cam. Now I want to try my phone. We're going to use the phone app to check this with. So if I come back here, you can see that we're coming up into the yellow. I'm just moving it back and forth across that cam. Do you see how the mark is coming? See how the mark is coming into the yellow? It's really, really lightly magnetized. This shaft isn't very magnetized, but it doesn't take very much. We're definitely into the yellow, and that's magnetized. So we have two different meters here that are both showing that this camshaft is very lightly magnetized. Okay guys, is that just too cool or what? Is this just an unbelievable little Subaru? Both cams are magnetized on this car. Never seen anything like it. This is a great car. This is a great, great car. Okay, so now We're going to have to figure out how the customer wants to proceed with this, because really the cams need to be replaced. But I guess the cams, the shop is telling me they're like $700 a cam. So I don't know the customer is going to want to spend $1,400 plus the labor. They might just want to get a used motor and put it in, but I think these turbo motors are pretty expensive used too. So I don't know, it's not my job. My job was just to diagnose the car. Now we know the cams are magnetized. Now it's up to the customer in the shop to figure out how the car is going to actually become fixed. The other suggestion that I've made to the shop is we could pull these cams and take them out to the airport and put them in a Magnaflux machine and demagnetize the cams in a Magnaflux machine. We also, in another video, I went over a degaussing machine I made. We could degauss them. There's a lot of possibilities, but normally what I've done with these type of cars is we've just replaced the cams with the shafts that become magnetized. It's really easy, and I know that's a good fix as long as you fix the grounds. Now both heads have grounds off of them. You gotta look at the grounds, and you gotta fix the grounds, and you gotta make sure that the cable going to the starter has a good ground. It'll be imperative to make sure that the car doesn't reflip it once you put new cams or shafts in this car. Okay guys, the shop has pulled the cams out of this little Subaru. Here's the cams here. So I want to show you a couple of ways that we test cams when we get them out like this for being magnetized. So I brought my orienteering compass in that I use when I mountain bike. So now let's just watch this. So now this is just one way that we'll pick up a magnetic field. Okay, so first we're going to do bank 1 cam. This is the one that we know is magnetized. We can definitely see that it's moving that compass. Now here's the cam that we didn't check when it was in the car. This is bank 2 cam. It's more magnetized than bank 1. Okay, so we can clearly see that these cams have an effect, and they're magnetized, and they're moving a compass. Okay, so we got bank 1 and bank 2. We know bank 1 was magnetized. We checked this in the car. And we can see that it's magnetized. We can see this little mark coming up. It's definitely magnetized. Now this is the one we didn't check in the car, and it's way more magnetized than the one we checked. So this one's got a problem for sure. Okay, so both cams are magnetized. We can clearly see that. I want to do one more test. Okay, so now we're going to use this tool. It's really accurate. It's for machining parts and certifying those parts did not become magnetic when they were machined. Once again, we can see it's magnetized. It's changing the number. This is the number here we're looking at. And we can see that this shaft definitely has more magnetic field than the other. It's definitely doing more magnetic field. It's pulling it up higher. So both of these shafts are magnetized. Bank 1 is less magnetic than bank 2, but both are magnetized. Okay guys, we know that the cams are magnetized now. Both cams are definitely magnetized, and they're causing the sensor to flip its field. Now I want to show you why that happens. So I've got a cam here and I've got it in a lathe. And I want to show you, here's the magnetic intensity. Now watch what happens when this thing spins. See how when it spins, it's going all the way high? Okay guys, what that's going to do, that's what the sensor is seeing. It's just seeing it all magnetized. And so the sensor can't deal with that because it's supposed to be changing the magnetic field high and low. But that's not at all what's happening here. We can see that when you have a magnetized shaft and it spins, that magnetic field is spinning and the sensor is just seeing that magnetic field. Well, the way these sensors work is it's got to be magnetic and non-magnetic so it can trip. When you have something that's just magnetic like this, the sensor doesn't know how to deal with it, so it will flip the field. It's real simple. Okay, now that we can see that when that magnetized cam is spinning, that magnetic intensity changes. So when the sensor is there and it's spinning, that sensor is exposed to a constant high magnetic intensity. Now the sensor is supposed to work with a magnet that's inside the sensor that goes across the element, and as that magnetic field is pulled down to the trigger wheel, it changes the sensor output. Now when that spins and I change that magnetic intensity on that sensor all the time, that's what's happening, and that's why this sensor is flipping its waveform. Now I had a few people comment that the sensor, but the lines of the sensor didn't change their location. So I want to talk a little bit about what's going on here. Okay, so first, I want all of you guys to start thinking like engineers, not like mechanics. Mechanics look at a line like that and they say it didn't move. An engineer understands that that line moved because I've got to tell the computer where the line is. What does that mean? Let me show you what I'm talking about here. Okay, guys. So right here, we have bank 1 and it's dropping, and we got bank 2 and it's rising. Now, guys, I've got to set a program that finds this edge. Now start to think about this when you think about things. Now we can see if we put a cursor down through these lines, and they're going to come down and they're going to touch where it's going to indicate where that is in relation, to the crank. So that's giving me crank relation. Okay, now we can say that if this flipped, that edge would still be in the same place. But no, that's not right, guys. If I program, I've got to program an edge, just like you would set your triggers up. So if you came over here to set your triggers up, you know how you set a trigger, a rising edge at a voltage. Okay, so let's say that we're going to set an edge. And let's say roughly we're going to set it at 2.5 volts through this waveform. Now, I got to call out in the program whether I'm looking for a rising edge or a falling edge, just like when you set your scope up. Now, if it's a rising edge, the computer is waiting to see the voltage go from a lower potential to a higher potential across my operate point. My operate point is the point where I program. That's the threshold. And once I break that threshold, the clock says that that's where this shaft is. Now, if that flips, that edge is in a different place now. So let's go look at where it flips. So right here we can see that we got an edge, and we can see that we're a little bit off here, because in our known good example, these edges were on this front edge right here. Now it's not there. But we want to get a little rev here. And I want to come in over here where we flipped. Now we can see where we flipped right here. Now we can see that if I was looking for this to be a different polarity, dropping or rising, now I'm looking at this edge. So before, this was being pulled down and this was being pulled up. Now they flipped. If I'm looking for a falling edge, I would be, normally if this didn't flip, I'd be looking for this edge. Now that it's flipped, I'm waiting to find this edge. Okay guys, remember when we started this whole process, we had a code that said the cams were advanced too far. Well, how do you set an advanced code? Well, you set an advanced code because when these flip, I'm finding the wrong edge and it looks advanced. Now the other thing that's really interesting is note when it started to get more intense magnetic field, that edge now is lining up where it should on the front, because the magnetic field is tripping this sooner because it's more intense. It's changing the location of where this is going to happen. Now these two edges are actually lining up like our known good waveform, which is close to the first pulse there. So I moved, but that's because the cam is magnetic. But that isn't even the main key. The main key, guys, is a computer knows nothing. It doesn't know anything until it's programmed. You have to program it. You have to tell the computer every single step, and if you miss a step, bad things happen. So when I write programs, I've got to call out these signals, and I got to call out where my operate point, where my threshold is, and whether it's falling or rising. And then the computer is watching it, and when it's at a higher voltage and it drops, if I'm looking for a falling edge, it's higher. When it drops, I'm going to find it. Or when it's rising, when it's lower and it crosses my op point or my operate point or my threshold. So if these edges invert, the computer is looking at a totally different place, and that changes the whole timing structure. That's why this car is setting cam advanced codes, because these sensors are flipping and it's looking for polarity. And the polarity has to be right. Again, remember, this is going up. Let me show you where this happened before we flipped over here. So we can see right here, we can see that this edge is right. Okay, so if I'm calling out a falling edge, I'm calling out over here. And if I call out a falling edge, I'm over here. If I call out a rising edge on the other bank, I'm here. I'm not here. Once these flip, I'm going to call the other edge out because the polarity changed. Let me show you that again. Now right away we can see when we started to spin the cam faster, the magnetic field affected the sensor for sure, and when it affected the sensor, it pulled it up here. But the problem, guys, is now that's a falling edge and not a rising edge. So the computer's waiting for a rising edge. It's going to call this edge out, not this one. And if I'm calling this edge out, not the front edge, but I'm looking for the polarity change, now look at how much difference that would be. Okay, that's a lot of degrees of crank rotation, guys. That's going to set codes and create stalling problems. And remember, that's what we're working on this car. Always deal with symptom diagnostics. The symptom, why am I working on the car? You guys got to keep asking yourself, why are you working on this car? Well, I'm working on this car because it's setting codes and the engine is stalling. It is dying. It isn't that these just flip. The flip is causing my problem. It's causing my DTC and it's causing the stalling. I mean, if these sensors are flipping and it's not giving you any symptoms, then I'm not going to chase this. But when I'm trying to fix the symptom of stalling and DTCs, I've got to chase that because this is where the problem is. As we've seen, both cams are magnetized. And when I got the cams demagnetized and put them in, this does not flip. But I want to make sure that we all start to think like engineers, not like mechanics. So the first thing is if this edge was in the same place, how come it set a code for over advanced cams? Because it's not in the same place by polarity. You have to program and you got to tell it whether I'm looking for a rising edge on a voltage or a falling edge, and they're going to build a model of this, and every one of these edges in these waveforms to build a model where I can get crank angle space identified, I've got to program edges in relation to each other in time. And if I don't do that, the computer can't figure this out. So if these sensors flip, it's going to find the edge in a totally different place because the polarity changed. So the polarity change is a major way that it's going to screw this program up, and it's not going to be able to figure out that it flipped because it doesn't know that. See, we all look at these cognitively and we say, oh, they're still really close in relation here. But guys, you cannot think of stuff cognitively. Your mind, when you look at this stuff, yeah, I see all this cognitively, like with my whole brain. But my business partner, Neil Peterson, is an unbelievable programmer. And I'm telling you, this guy has taught me how you do this. Everything has to be called out in the program, and if you don't call it out, you got to set how you're going to default the program. We call it else for default. And it's really interesting. And he's changed the world I live in. He changed it from me being a mechanic to me thinking like an engineer. How would I program it? Well, the first thing you guys need to ask yourself is if those edges are in the same place, how does it set the code? Because if they didn't move and they're in the same place, how does it set an over advanced code? Well, it sets an over advanced code, guys, because I broke the program. I'm no longer looking for, I flipped the polarity, so the polarity changes what edge I'm finding. And that's going to create havoc in a computer system. So the problem with this car is that the cams are highly magnetized. Now you always deal symptom diagnostics, guys. I live and die by that. I don't deal with DTCs as much as I do symptoms. I want symptom diagnostics. The DTC is just another piece that I put in my arsenal to try to figure something out. But it doesn't mean that that's what's wrong with the car. The symptom is why I'm here working on the car. It is stalling and I got a DTC, but I'm mainly worried about why this car is stalling. And the car is setting DTCs and stalling because these cams became magnetized, and now they're flipping these sensors, as we can see. So guys, man, do yourself a favor. Try to think like an engineer. Ask yourself, how could that do that? What would I have to do? How do I program things? How does this stuff work? It's really changed my life. My whole world changed when I started to do this, and I started to read white papers. And I started to think about how things work and how I'd have to build them and how do I have to program. And once I've written a bunch of programs for all of our tools and written some programs to run engines with when I was racing, I started to understand how this is done. But it makes a big difference in really thinking through how you see this stuff. Okay, guys. These are brand new cams. We can see these are from Subaru, came out of factory Subaru boxes. Now I want to take the compass and I want to do a similar test. We want to see if these cams are magnetized. Just because something's new and it came out of a factory box, don't ever count on things with just being right. I don't count on things like that. I want to prove that these cams are fine, so when we put them in, it's going to fix this car. So here's this cam. We can see that it's spinning that field. Look at it. That thing's more magnetized than the ones we're taking out, I think. Okay, guys, these cams are absolutely magnetized. The compass doesn't lie. It's just picking up a magnetic field. So that's one. So we've tested it with the compass. So now we're going to use the phone. And this is Smart EMF file. And what we're going to do here. Okay, so that's definitely pretty magnetized there. And this guy is not as magnetized, but it is magnetic. We can definitely see that it's magnetized. And that guy is really magnetized. These new cams are more magnetized than the ones we're taking out right now. I want to do one more test. Okay guys, what I want to do now is I want to use this instrument. This is a really accurate instrument. It's made for doing things like this. After you machine a part, you're trying to see if it's magnetized or not. And this will certify parts, and we can see that this definitely is magnetized. So both of these cams are absolutely showing that they're magnetized with every single tool I have here. So these new cams are definitely magnetized. Now if you put these cams in, you're not going to fix this car. You're going to have a really bad day. So we're going to need to degauss these cams, demagnetize them before we put them in. So that's what we're going to do now. Let me get my degausser set up so we can degauss these cams, because if you put these in right now, they're more magnetic than these used ones. And if these are more magnetic than these, we didn't fix the car. These cannot be magnetized. With the type of trigger wheel these have, if you have a magnetic field, it'll hold it up. It won't let it fall all the way down, and the car is going to stall. And that's what we're trying to fix, is the stalling and the code setting problems. This is the power supply we're going to use for this degaussing tool. And I'm going to roughly push 90 volts AC through this winding. And I've made a winding, and I got more winds. And what I didn't understand last time is I didn't have a big enough core. This center section, or the core that we took out of the transformer, was too small, and it would start getting really hot. Now that we've done this, what happens is if the core is not big enough, it starts to impede the magnetic field with reluctance and reactance, and so it won't work as well. So we're going to need a bigger core, and it needs to be laminated as we talked about last time. So this is a much bigger core with more power. I've got more voltage. So let's see what we can do to degauss these now. And if I put it up, you can feel it vibrate. And that's the AC going in and out of this. So we want to just go through and see what we can't get done here. This is a much smaller part than what we did with that crankshaft where we degaussed it on that Honda. Now to learn how to make this degauss tool, you're going to need to watch that Honda, the Honda Pilot. I'll put a link in this video for you. But that'll show you way more about what we're doing and how we're doing it. So let's see what we've got with this one. And you can feel the field with this. I mean, this whole probe is vibrating when I'm going up and down this. And that's the alternating magnetic intensity going in and out of the shaft. And that's what's going to take the magnetic energy out of this shaft, or to degauss it. So let's see what we've done thus far. Okay, I think I got these degaussed. Let's check this one first. It's slightly magnetized. It's barely moving that compass, but it still moves the compass. Let's try this one. Let's check this with the phone app and see what we are. Before this was getting into the red. We can see that it's not coming out of the green. It's fine. The phone shows that it's totally demagnetized. And then the most important tool to me is this other tool. Okay, so we've checked it with the compass and the phone shows that it's demagnetized. But this is the tool that's more accurate and sensitive. So this is the one I want to check. Now, before it was coming up to 3 and 4. Now it isn't even getting to 1. So these cams are definitely demagnetized, and I trust this tool. This tool is made for doing what we're doing right here. And we can all see the difference between going from 3 and 4s to we're 0.2, 0.3. It's way, way better. So these cams are demagnetized. We've degaussed them. So now the shop will go ahead and put these cams back in the engine, and we'll come back and test it. Okay guys, we're over at the shop for this little Subaru. They've got the new cams installed in this engine. They've driven this vehicle for over 100 miles. There's no check engine light, there's no DTC set, and the engine is not stalling. So the vehicle is fixed for the problems. But what we need to do now is to check the waveforms from the camshafts. So that's what we want to go ahead and do. Go ahead and start it up. Test it. Go ahead and give it a little snap. Okay, so what we want to do, okay, so now we can see that the bank 1 is going down, bank 2 is going up, and they're not flipping. So we definitely don't have a flip. Now I want to do that again. Let's do that one more time. I want to see it multiple times. I always check things multiple times. Go ahead.
So is it okay if I shut it off or not really?
Yeah, go ahead and you can start it, and yeah, you can shut it off. Go ahead and snap it. Okay, once again, we can clearly see that neither bank is flipping. Not bank 1, not bank 2. We're doing the exact same test as we did before, where we give it a little snap, and neither bank now is flipping. Start it and give it a little snap. Give it a little snap. Okay, guys. We can clearly see that neither of these cams is flipping. These cams are staying the way they should be, and this is correct. You can clearly see that the cams are right. We're not flipping the cams now. Before, what caused that flip was the cams were magnetized, and both cams were magnetized, as we've already seen. Now, I just don't know how you'd ever fix a car like this without a scope, guys. But this car is fixed. Is that just one crazy little Subaru or what? Can you imagine that you guys buy brand new cams from Subaru, and they're magnetized right out of the box. If you wouldn't have tested the cam and you'd have put it in this car would not be fixed. You would have the same problem. You would have taken out a problem and you'd have put the same problem back in, and that would really be confusing. Test your parts. Don't trust just because it's a new part that it's going to be okay. I mean, that blew my mind. The shop here is a really good shop, and he called me and he said, you need to come look at these new cams. I think they're magnetized worse than the old ones. And I told him there's no way. And then I got over here and he was right. They're magnetized more than the old cams. It's just hard to believe. Can you believe that's a brand new Subaru part? If you put those cams in this car, you would not have fixed it and you would have been really, really confused. It's a confusing car anyway. How would you fix a car like this without a scope, guys? There's no way. If you guys want to step up to the next level of diagnostics, let Automotive Test Solutions help you. If you don't know how to use scopes, we have online service where we'll log onto your scope live and help you work on your cars and help you understand how to use the scope and signals. Guys, if you want to get to the next level, Automotive Test Solutions can help you. Obviously, you can see this is the next level diagnostics and repair on this little Subaru. If you use scopes in your bays, you too will be successful.